Hello everyone and welcome to Lockdown Learner. Today's topic is stack in data structure. Earlier we have discussed like what is data structure, why we need data structure and about algorithm and time complexity. Now we are going to discuss about stack. Stack is basically a collection of similar data type. It is like same as an array you can say, and we basically implement stack using array and linked list. Now let us discuss something about what is stack mainly. Stack is a linear data structure which follows a particular order in which the operation are performed. Particular order in which operation are performed is mean insertion and extraction of an element. Like you can insert element in a particular order and you can extract that element into a particular order. That order maybe it's like LIFO or FILO. Last in first out or FILO, first in last out. Let me explain you one example. Suppose you go to a marriage and there is a waiter which is keeping plate and the waiter keep plate like first plate, second and third plate. Then suddenly you came and then you want to pick the plate. So which plate you will pick? The plate the waiter kept first or the plate the waiter kept last? Obviously the plate the waiter kept last you will pick. That is philo. Okay guys, the first we are ending is not going first out. There are many real life examples. It will be clear in like further slides. Consider an example of plates stacked over one another in a canteen. Okay guys, now let us explain you more about this. As we learn more about stack, like how is stack working, we have discussed like what is stack and some examples of stack. Now let us see how does a stack works. Now you can see here is we are having a empty stack. Okay guys, when we are putting data in this stack, when we are basically putting data in this stack, it is like going like downward. We are having, suppose we are having like a bucket, and in that bucket we are like giving like stones, like putting stone in that bucket. Okay, the bucket is filling and filling. And when you want to pick the stone, which stone you will pick? The stone you put first in the bucket or the stone you put last in the bucket? It's obvious. The stone you put first in the bucket means the last means the last you put in the bucket you will pick the first. It's obvious. The stone you pick like last time you have put like this stone, so this one you will pick first. Okay guys, this is example of stack. This is an example of stack, like how stack is working. So now we are having an element putting into the stack like push. Push is like a function in stack. Push is a function stack which we used to enter elements. To enter elements or like to give values to, like first we have put it once, then we have second. The stack is closed from like, the stack is like closed from here. Okay guys, the stack is closed from here. When I want to put out the data, so how can I put out the data? For okay, only thing I can do is like first I can put out 2. It's like input we have given, it's like 1 comma 2, and when we are trying to retrieve our data, so we are getting is 2 and 1. Okay guys, when I am giving input it's 1 and 2, and when I am taking out is 2 and 1. This is basically called stack. Popping is like deleting of data. Popping is like deleting of data from stack. Okay guys, now you are able to understand like how this thing is working, like how stack is working. Now let us see, like you have seen like how stack is working, like how the data is coming out and like what is happening basically. Now let us discuss some functions in stack, some operations basically. The operation we have discussed, first is push, second is pop. Pop is for deleting element, push is basically inserting, and then we are having a pop, that is deleting. And then the third one we are having is top. Top will always return you topmost element. top will always return you topmost element. Like when you delete, when you retrieve, like when you retrieve 2, like we have used like top function, and after top, suppose I've done pop, so pop will delete 2 also, and again I done the top one, the element left with me is 2, so the 2 will retrieve. Then when I done again a pop, then 1 will also delete, then after 1 will be like executed if there is nothing after 1. So for empty case also we are having a function is like is empty. Okay guys, is empty. Check whether stack is empty or not. Okay, it will display an error like underflow. And suppose the stack is full, because stack is having a like bounded stack is having like bounded capacity, because we are implementing in static, so it's an array, and when we are implementing in dynamic, it's an linked list. Stack is implemented using array. Don't get confused. In further videos we will see like how stack is getting implemented by array. And the last function like we are having is isfull. Isfull will check like full or not. It will display like overflow, sorry. It will display overflow of stack. Okay guys, now you are much aware about the stack and some functions. And stack is basically like on LIFO. LIFO is like last in, first out. Last in, first out. Okay guys, now we will discuss more about algorithm of stack in further. Okay guys, thank you. Okay guys, here we have discussed some operations on stack. Let us revise those operations and let us rediscuss that. First operation we have discussed is push. Push is basically used for inserting the data in stack. And second we have used is pop. Pop is basically used for deleting the data. And then we are having a stop. Top return the topmost element of the stack. When you like retrieving the element, so you have to delete that element. We have seen in this, like if 2 and 1 is there, suppose we have to retrieve 2 the tops and we have to pop it, then the top will become 1. Okay guys, so what we have to do is like retrieve like top, and then we have to do pop, and then we can retrieve those elements. And then we are having is like is empty or not, is full or not. It will check the stack is full or not. Stack have a bounded memory, bounded capacity. Basically it is used by implementing array. So array, as you all know, have a like capacity, bounded capacity. Array is not like expanding like linked list. Array have a bounded capacity, so stack is also having a bounded capacity because we implement stack using array. So by two ways we can implement stack basically. You can allocate memory to stack either using static memory allocation or dynamic memory allocation. If you are using static memory allocation, you can allocate by array, and if you are using dynamic memory allocation, you can allocate using linked list. Okay guys, now let us discuss some applications of stack, but like where we are using a stack. Suppose you have to like do undo. You have written in a text like in notepad like A B C D E. Okay, the first one you written is A, the last one written is E, and you have to like clear it. So it will clear A or E. It will always it will clear E. So that is like undo method like works, or the like clearing any things is work. And recursion is also on like this. Like it is a back tracing, you already know. Like from back we go on front. Like here like 2, first we inserted 1, then 2, then 2. From 2 we are going on 1. Not from 1 we are going on 2. We are going like backwards, we can say. Like you can use basically to reverse a string, and there are many more applications of a stack. Let us discuss the algorithm of stack. Let us learn more about stack. Algorithm of insertion of stack. Like in first step you are seeing here, like we are having insertion and we are having a, top, end and max. Let us discuss each. A is an array in which you have to insert an element which is item, and on top is the index on which you have to insert in an array. And max is like capacity of an array, you can say. Like number of elements, how can you insert in an array? Suppose you define int AR of, like capacity of an array is only 5. Okay, so what we are checking, like index is like not equal to max, then print stack overflow. Obvious, if like if we are using the memory which is not in our like case, like suppose array is defined of array of 5 and we are using the 6, so obvious we are going out of memory, so it is like stack overflow and then it will exit the program, it will not enter that element. If it is not overflowing that memory, so it will go in else part, in which it will increase top equals to top plus 1. Why it is doing top equals to top plus 1? Because in initial stage we define top equals to minus 1. So you already know that index started by 0, not by minus 1. So we are like increasing top by 1. Then it is, here is end if, then we are inserting item on top index on array A. You can see here like stack before and stack after when we are pushing. Okay guys, then again I put an element, then it will go here and here, and then when top reaches to the max, like top is minus 1, then 0, then 1, then 2, then 3, it is inserting the data, and then top reaches to the max, then it will give an error like stack overflow. Okay guys, now discuss it in briefly. Now you already know like max is basically, you can see this diagram, refer this diagram. This diagram will help you about this, like how we are inserting. Now you can check here some thing on like right hand side, what I have written, like if top equals to max, we are checking that our index should not greater than size of an array. I told you earlier also, if top is equals to size, then out of code will be print like stack overflow and exit the code. Else is increasing top by 1 because top is started by from minus 1, I told you also, and our index should start from 0 whole number, basically our index is a whole number, so we have increased top by 1. If top is less than max, then only it will input value on top plus 1 in array A, then it will exit. Okay guys, in next video we will learn how to implement stack using array, and after that we will learning like stack using linked list. If you are able to understand something from this video, kindly like this video and comment on this video and share with your friends. Okay guys, thank you.